Hello, everybody. Welcome to Science Sunday. This month we kick off a new season of Science Sundays. I'm just going to have a grab bag of topics this year. There's not going to be a unifying theme except for science.
All right, that's a good format to keep
Yeah.
in.
It's not like we have much to choose from. It's just everything we know to be real and true about the natural world. So, hopefully I won't run out of topics. I'm here with Mike Winter. I'm Scott Thompson. This is Science Sunday. I'd like to thank the DuPage Unitarian Universalist Church for continuing to host this and providing encouragement and practical support. It's just, what is this? Your 12th year of doing this, Mike? And my about 10th year or something like that?
Right.
It's really been fantastic. And one of the things that keeps us going is feedback. Tell us what you like, tell us what you don't like, tell us what you'd like to hear about. Maybe you would like to present a Science Sunday topic. Let us know. You can always leave comments on the YouTube videos, and you could also give thumbs up and thumbs down, etc. Let's see, I can't think of much more for an introduction. Mike, is there anything that you wanted to say before we...
No, I do have an email list, and if you're interested in getting on that, you could send a message to 19mike55@comcast.net, and any comments there get passed on with Scott and so on as well, too. I try to send very few emails out, just one announcing each topic so that people are aware of it, and anything else of high importance is very much talked about here more emails coming around to people.
All right. So thank you for tuning in. Thank you to those who are tuning in later. If you are tuned in live right now, I assume that everybody who's watching is alive. If you are tuned in live to YouTube right now, you may type in questions and comments into YouTube chat in real time, and Mike will be certain to catch those comments and questions, and we will address them. All right, well, today I want to talk about a topic that has been all over the news recently, probably for the past couple of years in different forms, 2 or 3 or 4 years. Once every decade or so, news sources and not a few government and military folks become breathlessly enthusiastic about the existence of what are called today unidentified aerial phenomena. I guess there are also unidentified oceanic phenomena as well, but that doesn't get quite as much press. To a large extent, what is today designated by the official agencies as UAP, unidentified aerial phenomena, used to be called UFOs, unidentified flying objects. Sometimes there's the more evocative term used, which is LGM. Do you know what that stands for?
No.
I'm not sure what it anyway. Oh, here is a note: little green men. So, not sure why it's always men. I guess spacefaring females are somehow not perceived by these people who witness these phenomena. Recently there have been a spate of news stories. I guess spate, is that singular or plural? Has been a spate.
Has
right?
been a spate.
Yeah, not have been a spate, so pardon my grammar. There has been a spate of news stories about these events, discerned from fuzzy film sequences, a chatter between fighter pilots, first-hand accounts, and a strange interplanetary object that visited our solar system a couple of years ago. This really happened. An esteemed Harvard astronomy professor and former department chairman, Avi Loeb, has written a book speculating that visiting object that came through our solar system was actually an alien craft. So some people are taking this very seriously.
It's a possibility, right?
It is a possibility.
Look at all possibilities.
And, you know, if an esteemed Harvard astronomer takes this seriously, perhaps we should as well. And when considering these things seriously, I think part of that serious consideration is thinking about the real universe, the science that we like to explore here, and what are some of the implications of what we know about the real universe related to the plausibility of interstellar travel.
Well, I mean, if you just have this one picture that you have showing on the screen right now, I mean, that's pretty definite. That looks like an alien, and it looks like a scientifically minded person in a scientifically contained kind of structure there, keeping this thing alive and so on, you know, providing this.
Right. I mean, you know.
Anything like this leads you to say
Well, right there's evidence.
Right.
That is hard evidence.
Why look at fuzzy pictures of things streaking through the air when you can see that?
When you can see this, right. Well, one of the problems is, and this has been a problem for decades, is that our ability as a species to craft tricks and lies and misdirection is really quite phenomenal. So, you know, it's easy to see special effects of an alien attack or an alien visitation in a movie and say, oh yeah, that looks so real. I bet that could really happen. You know, you see, I think this may be from a TV show, a still image from a TV show. You see this and you're like, well, you know what? That looks so real. I think that could happen.
Yeah.
And I want to talk today about, are there constraints and limits on what we are confident about regarding the natural universe that helps us understand what could happen? Let's see. The name unidentified aerial phenomena has been chosen by officials because it's not as provocative as UFO. Let's figure out what this new and subtle phrase is trying to tell us. Well, it means that there are objects seen in the air, hence the aerial phenomena. And the cause and exact nature of these phenomena are, not to put too fine a point on it, unidentified.
Okay. Hence the U in front of that.
Right, hence the unidentified aerial phenomena. Now notice in that very careful analysis of that definition, there was nothing about LGM and nothing about alien technology and nothing about anything except, that's funny.
Even an aerial phenomenon could be a light reflecting funnel, you know, in a crazy way, or many different things, not necessarily flying. So they're allowing for more things to be grouped in here, and they're not specifically identifying as flying or even an object. Right.
That's a great point, Mike. You know, we've all seen these spotlights. I hope all of us have seen these spotlights shining off of the bottom of clouds from car dealerships and whatnot. And here's this magnificently brilliant beam of light that you can't tell which direction the light is going or coming from necessarily. It could be a light funneled down from a cloud onto a spot on the ground, right? So optical phenomena, different densities of different gases in the atmosphere, little pockets of different density can create optical aberrations and whatnot. It's not limited to things made out of steel or neutronium or whatever that are being propelled magically or not through the atmosphere. It's just something observed in some, whether it's on a radar or on a photograph or whatnot, something observed in the air that makes us go, that's funny. But that's what science is. It all starts with, wonder what that is, or that's funny. All right. The U.S. military and other sober commentators encourage us all to not draw extraordinary conclusions from scanty evidence and snippets of video. All sorts of possible causes, from atmospheric or optical effects to human-made balloons, drones, missiles, and so on, could be behind some of these phenomena. In many cases, there's just not enough evidence to rule something in or rule it out. Thus, they remain unidentified. They're splotches on a recording or bleeps on a radar, and so on. Now, this does not mean they aren't interesting, disconcerting, or possibly even extraordinary. What it means is we don't know. Now, there are lots of things that we as a species still don't know after several centuries of science. We don't know what causes ball lightning. We don't know how quantum mechanics and gravity meld together, or why the corona of the sun is millions of degrees hotter than its photosphere, the area that emits the light that we see. And don't get us started about what we don't know about dark matter and dark energy. Humans have been speculating about the unknown for a very long time. Now, habitually, we've invented wild stories to explain the unknown. We've dreamed up accounts of gods and spirits, supreme beings, strange forces that act with agency or intent. Use the force, Mike. There you go. Let's see. Agency or heroes and villains from other planets. So I'd like to focus for a little bit on speculations made early on. This was at the dawn of the scientific era, when the church and the Aristotelian view of the universe and whatnot, Platonic solids and cycles and epicycles and so on and so forth, some of these things you may have heard about before, the church was still really in control in European society. And science was just getting started. So Giordano Bruno lived from 1548 to 1600. And he was a bit of a maverick. He had all of these wild ideas, and it made the church a little disconcerted. So he traveled around Europe, went to England, went other places to try and find an audience who would be receptive to some of his ideas. Now, some of you have heard about Giordano Bruno before.
We've talked about him a few times.
And, you know, one of the things that was interesting about his ideas is he speculated that the stars were other suns, and that these other stars might have other planets around them. And if they had other planets around them, well, perhaps they had their own civilizations. And if they had their own civilizations, well, maybe we're just one of numberless sentient species, sentient beings swimming in a cosmos full of other worlds and other civilizations. This was radical stuff, but not as radical as you might think, because some of the ancient Greeks had a similar idea.
Lucretius, I think.
Right, Lucretius and some other philosophers in ancient Greece. But Giordano Bruno took it a step further. You know, he was a Dominican friar, and one of the things that he speculated was that perhaps each of these worlds needed its own Christ. Right? I mean, just following the logic. Different planets, different peoples. Different people would have their own sinfulness and their own need for redemption, which means that there would be different Christs. Well, this idea and many others of his ideas were deemed heretical by these folks, the Inquisition. And this was ultimately fairly problematic, for Giordano Bruno.
Especially for him, right?
Yeah, especially for him, because in 1600, I think it was a September day. I'm not 100% certain about that, but he was burned alive in a plaza in Rome. And there's some speculation that Galileo Galilei actually saw Giordano Bruno's immolation. Galileo would have been a young man at this time and plausibly in Rome visiting. And so this might have made Galileo particularly anxious about what the church thought about ideas derived from speculation. Now, one of the things, in some sense, I think the story of Giordano Bruno is held up as a sign of free thought and scientific insight. Well, it's certainly an example of free thought, right? Being able to have an idea, crazy or not, being able to communicate the idea. And in a free thought society, one would never be punished for expressing ideas. Now, my opinion about Giordano Bruno is that he just happened to get lucky about several things. He happened to get lucky about the guess that the stars were other suns. He happened to get lucky about the speculation that these other suns could have planets. We now know that to be true. He happened to be lucky about the fact that life could plausibly arrive on other worlds. So,
Did you say arrive or arise?
Arise. Did I say arrive?
I didn't hear exactly.
Yeah.
I wanted to clarify.
I do mean arise. Life could arise on other worlds. Or arrive if you think panspermia has merit. Right? If there are bacteria or proto-bacteria floating in space that occasionally seed, quite literally, other planets. That's not a completely outrageous idea. But Giordano Bruno just happened to get lucky with some of his wild speculations. Today, he would probably be more correctly viewed as a science fiction visionary rather than a scientist, right? He didn't necessarily base his claims on careful observation. He was just thinking about what could be. Well, in the spirit of Giordano Bruno's speculations about life on other planets, we've seen some recent claims about possible evidence of life on other planets. So here's a fuzzy video captured by a Steadicam attached to a fighter plane. And a couple of interesting things about this video. It's got details about the orientation of the aircraft and the altitude of the aircraft encoded in this picture. It's also from an infrared camera. So in this context, black is relatively cool and brighter objects are relatively warm. I think this could be a negative. It could be the other way around, right? It could be that the dark object is the hottest object. I'm not certain. But
I don't think the government wants to tell everything about all their
possibly, yeah.
infrared cameras on fighter planes either.
So it's an infrared picture and it's fuzzy.
Could be filtered or something to show what looks like what is an object and what is gas or
Right.
something around it.
Yeah, I mean, I think it looks kind of like Batman, right? Soaring above the atmosphere in his Batwing.
Well, I don't think Batman flies, right? Superman more flies.
Well, Batman could have like a aircraft that's
Yeah.
kind of bat-shaped or
Okay.
something, right? But notice how fuzzy this video is. It's really hard to make out any detail.
Right, you can start guessing that there's wings on either side.
Yeah.
You can guess that there's like a central fuselage kind of thing, and you can guess that there's heat emanating from it.
Evenly, but not leaving a contrail or any other kind
Right,
of heat
yeah.
signature as an exhaust. Here's another one. This one's fun. See the little white dot in the upper left of this video frame. So This is another case where the video, some of the numbers there on the video encode some important information about the disposition of the aircraft that was filming this. Well, the secular, scientific, and humanistic communities have a great deal of overlap, philosophically and dispositionally speaking. And several scientific skeptics, for instance, have put much effort into analyzing these recent video clips of UFOs. I mean UAP. I strongly recommend, for example, the YouTube channel run by Mick West. If you do a search within YouTube for Mick West, M-I-C-K, West, he does a delightful job of explaining how infrared images, especially overexposed ones, can look like fuzzy blobs to the untrained eye and to the trained eye. Most of the footage we have seen recently has been from these infrared and not optical cameras. He's also done some wickedly cool geometry and trigonometry for us to make the plausible case that some of the objects we might naively think are moving supersonically are really just moving at speeds that a released Mylar balloon would move at. So this one in particular could plausibly be a small, highly reflective Mylar balloon or a weather balloon where the angle between the moving jet fighter and the surface of the ocean. Think about driving down the highway and you see a fence row. Well, those fence posts look like they're moving at a different speed than the more distant trees. Well, if you can work out the trigonometry entailed in that phenomena as well as other geometric arrangements, and the fact that the camera is not only moving but gimbaling, rotating and trying to keep this thing in the frame.
Focus,
yeah. Then Mr. West came up with the plausible idea that this is a balloon floating in an air current. It's not, in fact, moving hypersonically. He's also talked about out-of-focus lenses creating triangle shapes, blurs of brightness around unfocused lights. I don't have it in my slideshow today, but there's a recent video of this sort of triangular blinking light up in the sky. Well, it turns out that if you take some of these military cameras and you focus or unfocus them, the diaphragm, the iris in these cameras is triangle shaped. It's not round. It doesn't have many, many blades to make essentially a round opening like today's cameras used for landscape photography and whatnot. Instead, it's just got 3 blades and it has a triangular shaped aperture. And if it's out of focus, it'll make any bright point of light look like a triangle. And then he's looked at the frequency that the light pulses in that illuminating triangle and said that it's plausible that it's just the light of an aircraft, a regular terrestrial aircraft.
He's spending a lot of time and expertise and knowledge gained over a lot of years just to refute things that maybe people want to jump on and use as proof of their basic ideas, and it takes a lot of energy by somebody to actually disprove one, and then they just throw that one out and then use the 300 other items that he can't so easily disprove.
Yeah, cherry picking evidence, right? Cognitive biases. I really want this to be, I'm not speaking for me, I'm play acting here. Maybe I'll use a different voice. Talked about that earlier before the show started. I really want this to be an alien. This would be life-changing to me. I really want this to be an alien. So I'm going to look for all the evidence that supports my preconception and my wish, right? I mean, we all tend to do that in different contexts.
It's like what you say about sometimes people putting together documentaries that are going to disprove or prove a certain fact. They put a lot of energy and they've gotten money backing them, people behind them, all the effort and emphasis, and they're not doing it often. They're not doing it to give an even-handed view of all the ideas about it. They have an agenda, and they want to prove that the World Trade Center collapsed because of bombs strapped to
Right.
its struts at some point or something. And so the things that they emphasize and the points that they make support their basic idea.
Right. You know, another favorite of mine is nuclear power. You try to find a documentary on nuclear power, and every one that I have seen has an axe to grind, either pro-nuclear or anti-nuclear. It's very rare. Maybe I have seen one that's more even-handed, but certainly most of the ones I've seen
But it was
have.
boring.
I'm sorry? Yeah, those are boring, right? They're just like, well,
Present facts.
here's why it's good, and here's why it's bad, and here's why it's necessary, and here's why it's dangerous, and whatnot. You know, the sort of even-handed assessment of the evidence. But most documentaries, I believe, about controversial issues are made by people who have a particular bias.
If I can just put an aside, it seems like that also comes out nowadays when we talk about COVID-19 or the facts that support whether you should mask or not, or the facts that support whether you should vaccinate or not. All these things, you know, I've presented a Science Sunday that seems to me to have convinced me at least pretty well that you should get vaccinated. But there are other people that can take the time and effort and energy to put out other things, and each side kind of accuses the other of cherry picking data, like you said, and putting together the things that make sense to them.
Right.
And part of it, we have to realize we're humans and we're trying to understand things, wrap our minds around a complex topic. And part of it is to be willing to listen at least to other people's views, but at times you have to then go on and say, I've listened, and that's as much as I can do with what you're saying.
Well, Carl Sagan, one of his famous, endless supply of famous quotes, but one of the things he's made famous was the idea that you should keep an open mind, but not so open that your brains fall out, right? And this is often a criticism leveled against people who try to be scientifically skeptical about cryptozoology, Nessie and Bigfoot and whatnot, or UFOs, or crystal energy. I might use this later for a more detailed discussion of something. That they level against people who are criticisms of their outlandish or extraordinary claim without having extraordinary evidence. And they're just accused, people who refute this outlier claim are considered to be just not open-minded enough. So let's talk, let's see, I gotta find my place in my reading here. All right, there's more that this Mr. West has done, and I recommend his videos for those of you wanting to delve more deeply into the science and engineering specifics of plausible, more mundane explanations for some of these videos. Another point that Mr. West and others have made is that fighter pilots are highly trained professionals. They're trained to be cool under stress. They're trained to be masters of flight and weapons control systems on their aircraft. What they may not be trained in is the mastery of trigonometry or digital signal processing. They may not know much about optical engineering and possibly not be well-versed in ideas about critical thinking, cognitive biases, and science. There's a lot that any given person, even an expert in a particular field, doesn't know. And when you see something extraordinary or not easy to explain, given your current knowledge, it's prudent to call in other experts. Now, certainly armchair commentators and viewers of UAP recordings might decide that these are largely the effects of LGM or ET. Now, these humans jump to extraordinary conclusions given scanty evidence. Let's talk about little green sentient beings that might be out there in the cosmos somewhere. I think it's plausible that any alien beings would possess biological similarities to human beings, such as brains and some sort of digits to manipulate their environment. Certainly eyes. Most stars give off copious amounts of what we call visible light, and so on. In fact, I gave a whole Science Sunday talk about this last year, the plausible biology of extraterrestrials. I think a great argument can be made that simple life is very common in the cosmos. However, I do think that the chances of intelligent life evolving on a planet close enough to Earth to be relevant to us is minuscule. I genuinely think that that's the most plausible conclusion that one can draw from the lack of evidence we have about radio signals and other things from nearby stars. The chance that they've left, if there's an advanced civilization on some other nearby world, the chance that they've left their world to visit our world is, I think, even more minuscule. But I cannot categorically dismiss it as a scientific impossibility. Now, what I want you to think about is why such beings, if they exist, would want to come all the way to our planet to play cat and mouse with military aircraft or have late-night assignations with rural farmers. Also, why would they have the seeming agenda of leaving vague, fuzzy, questionable evidence? If they're remarkable enough to travel among the stars, they're certainly competent enough to stay off our radar, literally and figuratively. If a civilization becomes so advanced that they have the energy, the lifespans, the technology necessary to cruise the galaxy, then we've got nothing practical to conceivably offer them. What would we have that they would be interested in if they have a galaxy at their doorstep? Water, diamonds, iron, silicon, these are all abundant in the universe. So it's not raw materials that they might be after. Maybe they just want to be friends, like E.T. in the movie. Maybe they want to study us. Maybe they want to solve our problems for us. Maybe they're just itching for an easy fight. If you think that aliens are here to test the target acquisition and maneuverability of our fourth and fifth generation fighters, then why? If they're so advanced they can navigate the galaxy, I find it hard to believe they're worried about air-to-air missiles or lead bullets. If you take an anthropological view and suppose they're just out here out of curiosity, then why spy on farmers and fighter jets? The fighter jet issue reminds me of honeybees. It'd be like us being interested in honeybees with their dances and complex communal hives, only because we're really only curious about their stingers. I can see some merit in the so-called anthropological or zoo hypothesis. But if that's the case, it seems likely they'd either try to be super secretive and succeed, or they wouldn't be shy about getting our attention. If they want to be super secretive, they're screwing that up, potentially. If they want to get our attention, then heck, land on Harvard Yard with a solution to Fermat's last theorem or blueprints of a machine to remove excess CO2 from the atmosphere using futuristic fusion power, or even just pretty close-up pictures of a neutron star. All of these things would be extraordinary and well within the reach of a civilization that could travel among the stars. I'm not sure about Fermat's last theorem, but probably. Let's think about getting around in the universe. Now, we've all seen pictures of spaceships, again, in science fiction movies and television shows, but the practicality involved is really quite daunting. Consider a meteor. Meteors are hunks of matter that burn up when they hit Earth's atmosphere because they're moving so fast. They're not made of gasoline. They don't catch fire because they're volatile. They're moving so fast they heat up, and that friction with the atmosphere ablates away the material of the meteorite. One of the fastest airplanes humans have ever built, the SR-71 spy plane, had big gaps in the metal sheets covering its wings that were full of fuel. And that's because when it gets up to speeds of Mach 3.5, the heat from atmospheric friction heats up the metal and causes it to expand enough to seal up those gaps, and they stop leaking fuel all over the place. There are real physical engineering challenges to things like friction and propulsion that any real civilization using any real possible technology would really have to take seriously. The military has made a vehicle that can briefly attain Mach 9.6, or nearly 7,000 miles per hour. It exhausts a huge heat plume and burns through a tremendous amount of fuel to reach these speeds in a non-ballistic trajectory. Such machines, they shake, they rattle, they roar, they arc through the atmosphere, and they leave a hot streak of gas exhaust behind. When we think about going to Mars, we give the projects and rockets names like Starshoot and SpaceX Starship. This is highly misleading. These aren't between the stars ships. They're barely even one star system ships. Now, I recently did a calculation. This is meant to depict a box full of gas. Those of you who have studied a little bit of chemistry or physics know that there's this relationship between pressure and volume and temperature in a gas. And one of the ways that this information is conveyed sometimes is this imaginary thought experiment about molecules or atoms of gas in a box. Well, I did this calculation recently. I calculated the average distance between air molecules at sea level in our Earth atmosphere compared to the size of a molecule of CO2 or O2 or N2. So, again, the calculation compares the size of an atom in a gas, or a molecule in a gas, to the distance between the molecules in the gas. And then I did the same calculation for the typical size of a star and the typical distance between stars. Mike, which one do you think was less dense, and by how much? Half as much? 4 times as much? Do you have just a off-the-cuff speculation about that?
Well, when you think of the amazing distances that there are in the universe, you know, you'd think that it's less dense by a significant amount compared to air molecules that are constantly ramming into each other. The more I'm talking about, the more my number keeps getting higher, and I was thinking, you know, a smaller number, but I'm up at could see 100 or 1,000 times the density in a molecule in a box of air. Yeah,
you're on the right track. Now, I apologize. I kind of wrote this and threw this together. I've had some constraints on my time this week. I didn't put the number in here. It's in something else I wrote. But it's something like 10 orders of magnitude difference. Not 1,000 times, but a 1 with 10 zeros on it. Yeah. You know, 10 million times or so. And
you're saying that space and stars, if you'd compare them to a box in there, there's 10 million times as much space in the
Empty space,
empty
right?
space in the.
Yeah, so this is one of the reasons, for example, that when astronomers study the galaxy and the motions of stars, they don't really have to think about stars bumping into each other like gas particles would. They treat it as what's called an ideal gas, they could treat it as an ideal gas, which means that the molecules have zero dimension and they never collide. And that makes the simulations of astrodynamic phenomena easier. And frankly, there's not a lot of fidelity lost by assuming that space is full of zero-sized stars in a giant box of space. But the distance between stars is, well, not to overuse a term, astronomical, right? The distance between the stars is amazing. Space is really, really big. Space is unimaginably big and unimaginably empty. We can write down numbers to describe such things, but I think getting a real feel for it is humanly impossible. For example, it takes a light beam 4 years to get from Earth to the nearest star. At that literally blistering speed of our fastest military jet, the scramjet that's been tested, you think maybe it would take a little longer than 4 years to get there. Whoops, let me go back a slide here. So let's see if I can play this video. It's not wanting to play. Could you click on the video? There you go, thank you. So this is a real-time depiction of a light beam going around the Earth. Here's a light beam dancing between the Earth and Mars, or I'm sorry, the Earth and the Moon. And if you look carefully at this shows you a little beam of light zipping its way at a luminal velocity towards Mars. And then here is a similar light beam headed towards Earth from the sun. So light, which is the fastest speed that anything can go in the universe, is very slow when it comes to the distances between stars. And we can't hope to reach even 1% of the speed of light with our current technology. The speed of the things we build is so trifling, we can't hope to get to the stars with any conceivable technology. It takes 4 years for a beam of light to get even to the closest star, and that doesn't account for additional time necessary for a spaceship to accelerate and then decelerate. To get a spaceship to the stars would require more energy to accelerate and decelerate. Any plausibly large spaceship that could carry enough humans and life support to make the trip interesting. To get that spaceship to and from the closest star would take more energy burnt up as propulsion than humans have ever extracted by any means, nuclear, petroleum, solar, etc. It's just not conceivable that space travel is technologically accessible with any extrapolation of known technology. Now, there are other practical challenges to the idea of going on such a long trip. You better take a lot of snacks with you, because you may be traveling for 400,000 years if you traveled around 7,000 miles per hour, poking along through nothingness at any speed we're capable of attaining. It would be stultifyingly boring to spend so much time surrounded by darkness with no discernible change from day to day or year to year. It would just be boring. How would you fill your time? Forget about generation ships and suspended animation. That's the stuff of sci-fi that each have their own practical, incredible challenges. Also, consider how people cooped up in a spaceship surrounded by nothingness might spend their times, maybe they would get a little bit irritated with one another in that small space.
You said 400,000 years?
Yeah.
I mean, we think of 2,000 years as being an incredible distance back to the, Christian era starting, and 10,000 years since humans started agriculture.
Mm-hmm. Yeah.
I'm thinking, just amazing times way beyond that.
I talk about that a little while longer. I mean, 400,000 years ago takes us back before the human species, Homo sapiens, had even evolved, potentially.
Yeah.
Those are about 180,000 or so years old. I want to take a little time to talk about propulsion mechanisms. There are 4 forces of nature that we can use to grab onto bits of matter and make them move. One of them is gravity. We're all familiar with that. That's how the Earth moves around the sun, and the moon moves around the Earth, is by virtue of the effects of gravity. Electromagnetism has another name in common parlance called chemistry. It's the electromagnetic potential energy of chemical bonds that is used to eject matter from one side of a rocket ship so that the other side of the rocket ship, having left that mass behind, can be accelerated in the opposite direction. There are things like rail guns where you can use electromagnetism directly to accelerate something, but you can't build a rail gun a light year in length, practically speaking. We can barely get them to work on one aircraft carrier's worth of length. So electromagnetism and chemistry are the only plausible ways we've used to accelerate a terrestrially built spacecraft. You can use things like gravitational slingshots and whatnot, but those aren't going to get you anywhere near light speed. A recent star ejected from the supermassive black hole vicinity of our galaxy is traveling at 0.5% of the speed of light, and it's an extraordinarily quickly moving bit of mass. And that's from essentially a gravitational slingshot. And then there's the strong and weak nuclear forces, and those have no bearing on something like interstellar travel. There's nothing else. There are hints that there's some other kind of interaction that might have to do with neutrinos, might be another kind of nuclear interaction. But whatever that is, it's not long range enough or forceful enough to have ever showed up in any experiment ever done by any scientist throughout history, except maybe the way neutrinos wiggle. So these are the forces of nature at our disposal for building propulsion, and none of these is plausibly able to be captured and engineered to an extent where we can make a craft move between the stars in any plausible time frame. Now, that's another thing that I believe. I think that it's not so much speed and distance that we run out of, it's time. Our lifetimes are so short. If we lived for 1 million years, if this was our lifespan, the human lifespan was 1 million years, then taking a jaunty little 400,000 year trip to the nearest star might be something that the more adventurous among us might do. But then there are other problems. I don't know if I've written about this in my notes here, but consider wear and tear on things. I think I have gotten that. I'll get to that in a minute. If you were to hop in a spaceship and somehow try to travel at nearly the speed of light, you'd run into other problems. At about 20% the speed of light, and certainly anything faster, interstellar dust grains become lethal bombs, shredding any known material made from the 90 or so elements available for building things, not to mention the radiation dose that beings inside that ship would be subjected to. At that speed, you and your spaceship would burn up like a meteor by the rarefied atmosphere of empty space. The same goes for any other civilization, also limited only to the elements and forces available in the universe, who might aspire to interstellar voyages. They'd have the same limitations. I'll only mention in passing problems with figuring out how to make propulsion systems that can fling you between the stars and also take jaunty little sprints around the atmosphere once you reach another planet. Completely different problems. Magnetism won't do it, chemical propulsion won't do it, and once you get beyond chemistry and electromagnetism, you're pretty much out of options as far as the laws of nature are concerned. Some of you might be thinking about gravity and wormholes, but cutting to the chase, I can tell you, those won't work either. I just had to replace my air conditioner after 12 years or so. I had to replace a hinge on a door, and I had to replace a window frame that was being warped just by wear and tear. How many things have you had to replace in the past 2 or 5 years that have just worn out? Imagine building a machine that can last 100,000 years with moving parts. Mike, you build moving parts all the time. Can you imagine? Have you ever built anything that has lasted with moving parts, has lasted for years and years and years, that you didn't need to replace a part or do?
There's a lot of attention put into it all. We're using the most wear-resistant materials we can at times, but wear-resistant materials have other weaknesses to them too. They're more susceptible to breakage. And the ones that are more resistant to breakage wear a lot faster too. So just the type of materials you use. Then there's additions. We put coatings on, and we heat treat parts, and we do a lot of different things, but the coatings that you put on can enhance life and so on. But we're just making parts that make Weber grills or cans for the food industry, and part of our business keeps going because these parts wear out.
Well, there you go.
People are calling us up for more parts.
And that's not planned obsolescence, it's just nature doing its thing, friction doing its thing.
Right, yeah.
So I want to talk for a couple minutes before I close about things like Oumuamua. I mentioned the Harvard astronomer who thought we were visited by an alien spacecraft.
Looks like a giant marijuana cigarette to me.
I don't know what one of those would look like, so.
No?
Since Dr. Loeb came out with his speculations about the nature of Oumuamua, one of the things that it did is it very, very slightly accelerated on its way out of the solar system, but we didn't find any CO2 or other sorts of vapors coming off of it, knocked off by sunlight, and that vapor outgassing could plausibly accelerate something, and has been found to accelerate things like comets. Well, since this had no CO2 outgassing, people thought, well, I wonder why it's accelerating. Is it a spaceship? Oh my goodness, talk about leaping to conclusions. This is a belly flop, right? Anyway, since then, scientists have said, well, maybe it's a fragment of a planet or a planetoid, planetesimal. I'm sorry, what are they called? Dwarf planets now, like Pluto? Pluto is not a planet, just want to make that clear. Anyway, a fragment of something like Pluto that's made out of perhaps methane ices. And the methane ices would not have been detected by the instruments used briefly to look at Oumuamua as a little blob of light. It was too far away to discern any details like this. This is not a real picture. This is an artist's conception. So Oumuamua was likely just a fragment of some kind of extrasolar. Obviously, without any argument, it came from outside the solar system and exited our solar system, I think 2017, but it was probably a shard of some kind of exotic ice. Now there's other things like this thing called Tabby's star. And Tabby's star is this notion that there's a star that its light is being occulted or occluded by something. Its light is being attenuated significantly. Well, early speculations were that an advanced civilization had built something like a habitable shell around their star to capture most of its energy. Since then, The bottom right picture shows a star surrounded by really dusty cometary debris and whatnot. That seems to be the leading contender. Now, people looked for this advanced civilization shell. One of the properties it would have would be the emission of a lot of infrared energy, because if you use energy to drive your civilization, any kind of machine, etc., eventually it gets dissipated as heat energy. Energy is not created or destroyed, it changes form. And one of the lowest, least usable forms of energy is heat energy. So if they were using the energy of a star to drive a civilization as big as a shell of the orbit of the Earth, there would be copious amounts of infrared energy coming out of that shell, and that hasn't been found. This leads me to briefly talk about the Kardashev scale for energy capture that a civilization might use. There's Kardashev 1, which uses sort of planetary energy. Kardashev 2 uses solar system control and energy. You know, think about building colonies on Titan and the moon and flitting around between the planets. That would be kind of a Kardashev 2. And a Kardashev 3 would be a galactic civilization. And we have no evidence, at least in our galaxy, of any such civilization. And if it existed, it would probably have a longevity and a presence that would be unmistakable.
Well, and then you think, like you said earlier, the long span of time, and if there is anything that can get up to a galactic type of civilization, it doesn't mean that it's here now at the exact present time that we are.
Right.
And it may have been there before, or may never have been there either.
So if there are little green men jaunting about in our skies, then somebody somewhere on Earth should be able to use a good digital camera to make a good high-resolution record of their shenanigans. We've had so many out-of-focus, overexposed, shaky, indistinct images that we can... Could we get somebody with a Steadicam on the job? For now, it seems most appropriate to shrug our shoulders and recognize we cannot, in fact, draw many conclusions from the extant evidence, and certainly not extraordinary conclusions. Thus, we can rightly categorize these unidentified phenomena as not likely alien. It's enough to make a person think the problem of identifying these things might derive more from inherent difficulty of drawing sound conclusions from noisy data than anything else. To paraphrase a recent argument made by Professor Loeb, show me a high-resolution image or video of a flying saucer with "Made in Orion" stamped on its hull, and then we'll have ourselves a more substantive mystery.
Oh, that sounds like a challenge.
Yeah. Mike Albro pointed out to me kindly that, you know, it wouldn't be written in, you know, our alphabet or in our language and whatnot. Fair point. But the spirit of the argument remains the same. Some incontrovertible evidence of some technology completely outside our realm of access, but not one which violates any physical laws. Until then, I think we should chalk the breathless stories of alien visitations up to the same human impulse that makes us invent gods and superheroes and myths of beings malevolent or oh, by the way, this is an actual photograph of Tabby's star, not an artist's impression. It's just a star with some interesting spectral characteristics.
I haven't heard about Tabby's star.
Yeah. Anyway, it's the same impulse that makes us invent gods and superheroes and myths of malevolent or benevolent beings who want to tamper with, trick, mate with, help, or hinder humans. Aliens are just another version of that impulse to look hopefully or fearfully at the stars. We've even invented a story about an alien, godlike being who comes to Earth to save us from all manner of perils. And that's my favorite superhero, Superman. He's sort of the best of all possible worlds. I think it's prudent to realize that we are isolated in space, and that the only things with limitless reach are our imaginations and our telescopes. As for benevolent salvation or malevolent destruction, that is entirely up to us. And then one final point, I've spoken about this in the past, but I think if you really want to connect with a foreign intelligence, some entity that has a different view about the world, has something to teach you, maybe you have something to share with them, just look next door, right? All of us are a universe of possibilities that remain largely unexplored. Thank you. Mike, do we have any questions or comments?
No, it sounds like people were pretty much wrapped up in watching it or going to watch later, and
Okay.
so no comments coming in right now. We probably have a minute or so if you type something in fast, but yeah, very, very fascinating. It's hard to say. There's one aspect you said in terms of they have to show you something that is plausible and understandable, yet not something that we can achieve. And so that gets a little bit challenging in that way, because is there a possibility of something that we don't know about that they're utilizing and using? And you have to, as a scientist, you have to open up that possibility as well too. And that allows a lot of wiggle room for people that want to be conjecturists or whatever to slip in.
Arthur C. Clarke famously opined that any sufficiently advanced technology is indistinguishable from magic. But there's a counter-argument to that, and that counter-argument is that there are limits that we have already discovered about what's possible in the universe. There are 4 forces. There's not some other force that exists that can propel matter or levitate matter other than electromagnetism or exhaust, F equals ma kind of reaction mass. If there were such forces in nature, they would have shown up in particle physics experiments. They would have shown up in some of the other things that we see. They would have shown up in strange properties of the spectrum of stars and neutron stars and other exotic things in the universe.
Right, when we get our look at the universe, we see things traveling on in a pattern throughout the universe that mimics or seconds what we know about here.
Right. Everywhere we look, from close by to stars that are billions of light years and billions of years old, billions of light years away and billions of years old, we see the same physics playing out that we see here on Earth.
The same spectral results. When you look at the stars, the elements are the same, the powers are the same. Yeah.
So sure, technology is going to advance. I mean, there have been incredible technological advancements even in the past 20 years, which is one of the Science Sundays I want to give this year, about advancements in the past new century. But, technology advances, but our fundamental understanding of science has now gotten to the point where the wiggle room exists in the boundaries of theories like gravity and quantum mechanics. But any new theory of gravity and quantum mechanics that might meld the two is going to preserve everything we know to be true with absolute confidence about the way particles and planets move in their orbits.
And dark energy can't have any aspect. I mean, we don't know a thing about dark energy, and I would say that a conspiratorialist or whatever, or a conjecturist would say, well, once we find out about dark energy, that's more than 70% of the amount of matter and energy in the universe. We'll have all new ways, and someone that's solved this will now have methods and techniques that will blow our socks off, literally. Right.
Yeah, one of the things about dark matter and dark energy is that they don't, especially dark matter, doesn't couple to regular matter. It doesn't exert any force besides gravity, which is why it's so hard to detect. And then dark energy is just, as far as we know, is just a property of space that is immutable. You can't tap it, you can't change it. It's just the way space-time exists in our universe, that as it expands, it fills up at a constant rate with a background level of energy that isn't zero. Using that for propulsion, I can't imagine, well, maybe that's me and my limitation of my imagination, but I can't imagine how you would sort of couple to that and use it to, it's the same everywhere locally in space. And so you need an energy gradient to create propulsion. And how can you create an energy gradient out of something that doesn't change except over, a billion light years worth of distance? Mm-hmm. All right.
Great, wonderful. Science Sunday will be back in a couple of weeks. I'm kind of talking about some of the things that we explored a little bit 2 weeks ago when I got interested in Beringia, which is the land up in the Bering Strait, and the path and the way that people traveled to the New World, and then wanted to talk maybe about megafauna. So a few of those topics will be maybe over the course of the next few Science Sundays for me.
Excellent. Thank you. Oh, just 1 second additional thing. I've got this, I brought this quartz crystal for a reason. So this crystal is made out of some common elements. People talk about aliens maybe that have a biology based on something besides carbon. Well, I can make carbon dioxide, and we make it all the time with our respiration. It looks like this. It's transparent, but it's gaseous, and it reacts readily chemically. Well, if you try to create a life form out of silicon, this is silicon dioxide, right? So instead of carbon dioxide, silicon is a moderately gregarious element as well, and you can make silicon dioxide. But it tends to be bound together with much greater energy, and so using it in biologic processes where you need solubility and transportability and being able to engage in lots of different chemical reactions, silicon just doesn't fit the bill. But fortunately, the universe is full of carbon and nitrogen and oxygen and other plentiful elements. So one thing we can say about aliens is that if they exist, one additional thing, they're probably made out of carbon. So we can plausibly know some things about aliens that are based on solid science, but the fact that they might get here or not so much.
Someone talked about Einstein-Rosen bridge, accelerate through space.
Yeah, the problem with the Einstein-Rosen bridge, there's this notion of it's a kind of wormhole. Problem is keeping the mouth of the thing open on either side of the wormhole, tunnel between two locations in space-time. I'm not going to get into detail about it in our time remaining, but keeping the wormhole open is a big challenge in terms of energetics. How would you do that? Another big challenge is if you go into the wormhole, it looks like you might still be fried because of the intensity of radiation and whatnot. So, serious theoretical physicists have spent serious time thinking about these wonderfully speculative concepts, and they just don't seem to lend themselves to any practical means of transportation. So.
All right, great. Well, thanks so much. Appreciate upstairs, Justin, and all of you for signing in and watching, and thanks a lot for Science Sunday visitation. There are some possibilities of coming in and being part of the studio audience. If you email me and let me know about that, we're looking for a few people who want to come in here and participate in it with us, socially distanced and so on. You're welcome to do that.
Okay.
And let me know. And thanks so much, Scott. Very interesting. I think I learned a lot about
Thanks to all.
life.
Thanks to all you who tuned in now and who will watch this later. See you soon.
Thank you.